Today we're going to do application word problems with displacement. So in other words, there will be a phase shift with all of these, and I'm going to work 3 different examples with you. Okay, first one, John is floating on a tube in a wave tank. At 1 second, John reaches its maximum height of 14 meters above the bottom of the pool. At 9 seconds, John reaches the minimum height of 2 meters above the bottom of the pool. Sketch the graph that expresses John's height from the bottom of the pool with respect to the time, and then write the equation. So we know time has to be here on the independent axis, and we're going to write our height right here, and this is in terms of meters. All right, we're thinking about how far he is from the bottom of the pool. We are going to use our x-axis line right here as to represent the bottom of the pool. So we know the minimum height is going to be 2, and we know that the maximum height right here is 14. From that, we can determine the midline of the graph because it's halfway in between. We have a difference of 12 right there. And if we cut that in half to get the halfway point, we would get 6, meaning we have to go 6 below 12 and 6 above 2. So if we go 14 minus 6, we get to 8. If we go 2 plus 6, we get to 8. So we know our midline is going to be 8. That is going to be represented by our d value. Now, it says right here at 1 second, he's at his maximum. So he's at the maximum right here at 1 second. And then it says he's at the minimum of 2 meters at 9 seconds. So now the sun way over here at 9 seconds, he's at the minimum. Now, we know that if we are at a maximum and minimum, halfway in between, we have to be at the midline. So let's figure out halfway in between these 2 points. So the difference here, 9 minus 1 is 8. And 8, again, I'm cutting it in half. Divided by 2 is 4. So I'm going to add 4 to this or subtract 4 to this, just like I did with my midline here. And that'll tell me that I'm at 5. Each tick mark is going to represent 5. And what I have to do on this problem is I have to complete my cycle. So I'm going to have to add 2 more tick marks because I haven't completed my cycle yet. I've only gone halfway through right here. So I have to keep going to get to the other half. So if I add another 4, I'm at 13, and adding another 4, I'm at 17. That is my cycle. Now, once this is graphed, I don't know, by the way, I don't know exactly where this is going to meet there, and that's why I kind of left that blank right there. Once I have my cycle, I can then write my equation. I can now determine if it's sine or cosine, and how I know that is dependent upon where it starts. Where I'm going to start this is right here with a phase shift of 1 second. So if I start it right here, I'm going to write it as a positive cosine because that's at the maximum. If I wanted to write it as a sine, a negative sine, I could start right here with a phase shift of 5, going right 5. If I started right here, I could write this as a negative cosine. If I wanted a positive sign, I could go here. And any one of those would be correct. But again, I'm going to do mine from my blue dotted line, and I'm going to write this as a positive cosine graph. Okay, I have my d value. I know I complete 1 full cycle at, well, my last tick mark was 17, but it doesn't take 17 seconds for me to complete 1 full cycle because I started at 1. So I need to find the difference between these, which is 16 seconds. This right here is my period in which I've completed 1 full cycle. So I can take 16 and set that equal to 2 pi divided by b, just like I did before, and cross multiply, set them equal to each other, solve for b, and when I do and reduce my fraction, I get pi over 8. So I have my b value, I have my d value. My amplitude, my height of my function is this right here or this right here which was 6. That was right here. So that was my amplitude. Because I'm writing it as a positive cosine, it is going to be a positive number. And the only thing left I have to do is my phase shift. And remember, we started at 1. So we had a phase shift right here that was going right 1 second. And that would equate to a -1. So when we write our equation, our a value comes first, which is 6. And then we said this was a cosine. Our b value comes next, which is pi over 8. And then in parentheses, all we have to put is an x minus 1. And then when we add our d value, we get an 8. So this right here is my solution, and I'm going to leave it just like that. And the only thing I could do to make this even better is change this to an h of t, height with respect to time, and change my x value to a t value because it represents time. But I'm not going to worry about that. If you give me this answer, that's perfectly acceptable. I know you're used to working with x's. Okay, the next problem is about a mass that's bouncing up and down on a spring hanging from the ceiling. Its distance, y feet from a ceiling, varies sinusoidally with time t seconds and makes one complete cycle every 1.6 seconds. At t equals 0.4 seconds, y reaches its maximum height of 8, and the minimum it gets to is 2 feet. Okay, and it says to write an equation, and of course we have to graph it. So what we have is we have this mass that's on this like spring right here that's hanging from the ceiling, and it's bouncing, it's going up and down. As we're graphing this, we want to know how far this is from the ceiling. We're going to kind of imagine we're flipping our ceiling. This right here is going to represent the ceiling. Okay, so we're going to do the distance that it is from the ceiling. We're going to do the maximum and the minimum distance. So the maximum distance we know is 8. We know the minimum distance is 2. That's coming right from the information. We also know it completes one cycle every 1.6 seconds. So this is our time here in terms of seconds, and this is going to be our height right here in terms of feet. Okay, so it says at 0.4 seconds, y reaches its maximum height. So as high as we get right here happens at 0.4 seconds. And then it tells us the minimum it gets to is 2 feet, but it doesn't tell us when that happens. Well, what we do know is that we complete one full cycle every 1.6 seconds. So if we take and add 1.6 to the starting point here, we would get 2 seconds. And what we know is at 2 seconds right here, we have to be back to where we started. Halfway in between here, we have to be at our minimum. So let's figure halfway in between there. The difference between 2 and 0.4 is that 1.6. If we cut this in half, we're at 0.8. So if I add a 0.8 to this and subtract a 0.8 from this, I should get to my midpoint. This is 1.2, and when I subtract, I also get 1.2. Now, I can also get the halfway point here and here by doing the same thing. By taking 2 minus 1.2, that gives me 0.8, and dividing that by, by 2, and that gives me 0.4. So I could add 0.4 to get that. And same thing here, I could add 0.4 here to get that. So there's my scale. And the important things that I need on here, if you don't give me all of it, it's fine. I need this, and I need this. So those 2 midpoint ones, I'm not going to mark it wrong if you don't give me those 2 values. Okay, now you can see I don't know what's happening over here, but I am going like this, and it's going to flip down. And that, the way it's graphed, is a positive cosine. So again, I'll write this as a positive cosine function. Now let's find this midpoint right here, halfway in between. If I go 8 minus 2, I get 6. If I divide that by 2, I get 3. So I'm going to subtract 3 to get 5, or I could add 3 to also get 5. The 3 value is my amplitude, which will be positive because I'm writing as a positive cosine. My B value I'm going to get here in a minute. C value I'll get in a minute. My D value is my midline, which is 5. This does have a phase shift because this is where I'm starting. I'm moving right 0.4. So my phase shift is going to go right 0.4. So in other words, it's going to be a subtraction sign because it goes in the opposite direction. My B value is coming from my period, and my period is 1.6. So if I take 2 pi and divide it by 3b, and set that equal to 1.6, and cross multiply here, I get 2 pi is equal to 1.6. And when I divide both sides by the 1.6, what you're going to see I get for B is this, 2 pi over 1.6. And guess what? This is mathematically incorrect to write that. So what you are going to do is this. You're going to go to your calculator. In your calculator, you're going to go 2 divided by 1.6. So just plug in this part right here, not including the pi. You're going to hit enter, and you're going to see you get 1.25. Now convert that to a fraction by doing math, enter, enter, and you're going to see you get 5/4. What you must give me for a B value is 5/4, and then take the pi back on. So 5 pi over 4. Do not leave it as a fraction and a decimal because that is mathematically incorrect. So 5 pi over 4 is my B value. I can now write my equation putting all this together. I have f of, I can do x, I can do t, I could do, I'm going to actually write it the other way. I don't care if you do f of x, but I'm going to write it as h of t, so the height is a function of time, is equal to my a value, which is 3. I said this is a positive cosine. My b value is 5 pi over 4, which goes outside of the parentheses. My x is x minus 0.4, and then I'm going to add to it my d value, which is 5. And the only thing I'm going to do is change my x because I was doing this in terms of t. So I'm going to change my x value here to a t. Again, I don't care if you use t or if you use x and f of x, but this is what your answer should be. What I do care about is that you write that way instead of that way. Last problem. Researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. 35 minutes after they start timing, it reaches its highest temp of 120 degrees. 20 minutes after that, it reaches its low of 104. And we're going to sketch and write the equation. So what we have here is we have time. Again, this time it's minutes. And this time we have temperature up here. And temperatures in terms of degrees. So what we know is we have a maximum of 120 degrees, and we have a minimum of 104 degrees. Notice this is not to scale. Now I'm going to have to find the midline here. Let's just go ahead and do that right away. So I'm going to do 120 minus 104, and that gives me 16. When I divide that by 2, I get 8. 8 is not my midline. 8 is my amplitude. But I'm going to subtract 8 here to get 112, or add 8 here, of course that would be plus though, to get 112. And 112 is what represents my midline or my D value, sorry. Now let's start graphing this. It says 35 minutes after it starts timing, we reach our high. So right here happens at 35 minutes. 20 minutes after that, it reaches the low. So if we take and add 20 to this, we'd be at 55. That's our low temperature. Well, guess what? To get back to my high temperature, I have to add the same distance. So I have to add another 20. If I add 20 to this, you can see I get 75. There's my sinusoidal function. Again, I'm going to write this as a positive cosine function. Actually, you know what? I'm not. I'm going to flip this one, and I'm going to write it as a sine function. So I'm going to write this as a sine function so you can see how to do this. Now, in order for me to write this as a sine function, I have to start on the midline. So I have to start here if I want it for a negative, and here if I want it positive. Well, I'll go ahead and write it as a negative sine function and start right here. So I need to know the difference here, or what this point is. Well, if I take and subtract these, I get 20. If I take 20 and divide it by 2, I get 10. So if I add or subtract 10, you could see I'm at a midpoint of 45. If I wrote it as a positive sign, I would do the same thing and but have a phase shift of 65. So my C value for this is going to be right, so a minus 45. And the only thing left I have to find is my B value. And let's go ahead and do that. We need to know how long it takes to complete one full cycle, and I was never given that information. But when I go here to here, that's a complete cycle, and that is from 75 seconds, or minutes rather, to 35. So that's equal to 40. So my period is 40. So I'm going to take 40 and set that equal to 2 pi over b. Cross multiply, set them equal to each other, divide, and I get my b value of pi over 20. I have everything I need, and I'm going to write this as a function, a sine function, a negative sine function. So this is going to be, I'll just do f of x and x again. F of x is equal to a negative 8 because I'm writing it as a negative sign. My b value is pi over 20 outside of the parentheses. Inside I have x minus 45, and then I'm going to add to it my d value of 112. If I wrote that as a positive sign, the only difference would be my phase shift right here would now be x minus 65. Everything else would stay the same, with the exception of the sign in the front. It would become positive. So there you can see two different ways to write this. And the reason I did that two different ways is because on your homework, which this is your homework, you will have an problem in which you have to write a particular way. Likewise on the test, so read the directions carefully. If it says to write it as a sine function, you have to write it as a sine function. If it says cosine, you have to write it as a cosine. If it says positive cosine, positive cosine. If it doesn't clarify, write it as positive or negative. There's your homework. Go ahead and submit it to Schoology when you're done. And if you have any questions, let me know.